Hello, these are Solidworks 2016 tutorials. Now in this video we will show you how to use different add-ins in Solidworks. So we'll show you how you can use flow simulation and simulation. So in order to activate this flow simulation, you can simply right click here and click on flow simulation, and there you have your tab. Now what this does actually is it creates a simulation of fluid flow around your part. So let's just create a part like this, let's say. Okay, just for fun. Let's say this is a small car. Okay, really ugly car, but that's okay. Let's say this is 10 inches long, and let's say this is 4. Doesn't really matter. Let's say this here is 2. This is 1.5. This should be, let's say, 4 or 4.25. Okay, now let's just extrude this, and let's say 4 as well. Now let's just go to midplane and click OK. So now we have our car or something like that, and let's just go to flow simulation and click on wizard. Okay, so we need to save first file, so let's say flow sim part. Now let's click on wizard. Okay, this box appears with where you need to add your project name. So let's just say car flow simulation. Use current configuration or select or create new. Let's just click next. Now we need to define here our unit system, so we can see these predefined or create new one. You can see some of the parameters that you can change and units that we'll be using for that. So let's just use this SI. Okay, now we can select two types of analysis, so internal and external analysis. Now in an internal analysis, fluid goes through, let's say, pipes, and in external it just goes in space around your part. Now in here we can exclude cavities without flow conditions, exclude internal space, etc. Now we will select external, and also we can here choose to turn on our heat conduction and solids radiation time dependent, so we can specify amount of time that we want this experiment to last. And we can also expand this if you want to and see everything. Also we can include gravity, but we don't need that right now, and rotation, etc. Now also we can select here reference axis, click next, and now let's choose our default fluid. So in this example we'll use air, so we'll just double click on air, and we can select here humidity, high Mach, number flow, we won't have that, etc. Also flow type, we can select laminar and turbulent, we can select laminar only or turbulent only, and click on next. Now we need to select wall conditions, so we don't have heat exchange in here, so it doesn't really matter. Let's just click on adiabatic wall, and now let's just add our parameters. So we need to add our, in this external analysis, we need to add our velocity of air in X direction, obviously, because car will be moving in this direction, so the air is flowing in that direction. Okay, so let's just say our car goes, let's see, 60 meters per second, and click on finish. Okay, now we have this domain that we'll use for calculation, so let's just edit the definition of this, and let's just make it smaller so we don't. Okay, let's just go like this. Okay, now we can move this a bit there, this there. Let's move this a bit. Come on. Okay, great. Now with smaller domain we have faster calculation, so basically if you have symmetrical parts you can do simulations for only one part and see everything. So in here we can just move this part to the half of this because this part is symmetrical. Now we can add boundary conditions if we want to, and there are different boundary conditions, so you can add flow openings, pressure openings, and walls. We don't need any of these in our external analysis. We can also specify mass flow, volume flow, velocity, etc. We need to also select faces to apply boundary conditions, and we need to add goals. So let's just click on insert global goals, and in here we want to, let's say, calculate forces of drag and let's say downforce. So let's just find our forces, click on Y and X force, click OK, and now we can create mesh and just do the calculation. So simply click here on run and new calculation, mesh, okay, and let's just click on run. Now our ghost simulation is calculating everything, so you can just follow the whole process in here. Let me just pause for a while. Okay, so our solver finished all the calculations, and as you can see we had in total 53 iterations till we found or calculated all the things we wanted to know. Now let's just create something like this just to show you. Okay, so let's go mid-plane for, okay, no, okay. Now let's just go to our simulation tab and go to results. Now if you want to see those, you can just click on insert goal plots and you can select both of these. Now you can either export it to Excel or just show them. Okay, so we can see that our X force, so drag, was 11,000 newtons, and we had almost none of the Y force. Okay, so Also we can see different plots, so let's just click on this. Okay, on front plane, let's just say contours, and let's just say velocity in X direction. Click OK, and now we can see air velocity in here. Now we can add a definition and maybe add vectors as well. Now you can see that. Okay, let's just hide all. And also you can insert flow trajectories. So let's just select this plane here. Let's say pipes velocity and click OK. So it failed to complete. Let's just clear this and let's select this plane. Okay, and now we can see how air actually moves around our model. Also, if you want to, you can go here and let's say play, and you can see how air flows around our part. So basically that's how you create flow simulations and how you can use this to calculate different things you want to know. Now let's just close this and let me create a new file, and let me show you how you can use simulation, so FEM analysis. So if you go to add-ins, you can select Solidworks simulation, and you can even start it on startup if you want to. Let's click OK. So we have our add-in prepared, and let's just turn it on, and let's first create our part. So let's create a plate, something like this. Let's say this is 6 inches, this is 0.25, and let's just extrude this 2 inches. Okay. Now with simulation we need to create study, so let's create new study so we can choose between these, and now we need just static study. Click OK, and now we get this tab here. So we have our part, we can add connections or fixtures, so let's just add fixed geometry. So let's just fix this in all 3 directions, and let's just add external load, so you can add gravity, pressure, torque, force, etc. So let's just add force here of 1000 Newton. Click OK. Now we have everything. We can just click on run this study, but first we need to specify our material. So let's just apply some of our favorite materials. So let's say this alloy. Okay, and now we can just run this study. So let's wait for a while, and this is what happens. Okay, so basically here on the right side you can see von Mises stress, and you can see that because stress is in here, okay, so if you double click on this, you can change your chart options and definition, so you can select something different. So for example, normal stress or anything you want there basically. Also you can show maximum rotation and minimum rotation. Click OK, so we have maximum stress there. Also you can see our displacement, so we have the biggest displacement there, and strain as well. So let's just right click on here, and we can click on animate, and we can see what happens here. So with this simulation tool we can do all kinds of analysis with our parts, and we can even, based on this data, you can optimize your part. So let's just close this, and that's it about simulation and flow simulation.